Okay, imagine you're standing right there on this historic bridge. You can feel the structure under your feet, maybe the sun's out, and you're looking out at this really beautiful river flowing by.
Hmm.
This bridge, it connects two places, right? Stillwater, Minnesota, and Holton, Wisconsin.
Yeah.
And it spans the St. Croix River.
Yeah, it sounds like a pretty straightforward picture, doesn't it? Just a connection.
Right.
But the story of this specific bridge, the Stillwater Lift Bridge, it's really not simple at all. It's got this whole rich tapestry, layers of history, quite a bit of conflict, actually, and some genuinely fascinating engineering stuff, too.
We've pulled together, quite a bit of information about it, case studies on environmental fights,
Hmm.
reports on these really advanced inspection techniques they use now.
Yeah.
So our plan here is to sort of unpack all of that. The history, the controversy, the tech side, really try and bring this place to life for you.
And this lift bridge, it's sitting right on the St. Croix River, which, as you mentioned, has this special status. It's part of the Wild and Scenic River system.
That sounds important.
Oh, it is. That designation isn't just some label. It's really central to understanding a lot of the complexities around this bridge.
Because for years, many, many years, there's been this fundamental tension playing out right there.
Hmm.
You've got, on one side, this clear need to improve local transportation, make it easier for people to actually cross the river.
Sure, makes sense.
But then on the other hand, there's this really strong desire to preserve historic resources, like the bridge itself, and protect that very special environment, the Wild and Scenic River.
And this tension, it's not new. Discussions about how to improve things right at this spot between Stillwater and Holton, they actually go way back. We're talking the 1950s.
The 50s, wow. So this has been going on a long time.
A very long time. But things really heated up later, in the 1990s. By 95, the federal and state transportation agencies, they'd landed on a plan.
Okay, what was it?
Build a completely new bridge. And crucially, the plan included removing the historic lift bridge.
Removing it entirely.
That was the plan. And it immediately ran into significant opposition. An environmental group challenged it legally, took the agencies to court,
Yeah.
and they won. They successfully blocked that decision.
Okay. So fast forward maybe 5 years to the year 2000. What's the situation then?
You had, well, a classic gridlock. 3 really important public goals: better transport, saving the historic bridge, protecting the river, all seeming totally incompatible.
Right.
And the different agencies involved just couldn't find a path forward together. They were stuck.
Exactly. And that's kind of where the story takes an interesting turn, towards trying to find a way out. In 2001, realizing they were at this total impasse, the Federal Highway Administration and the transportation departments in Minnesota, Wisconsin, they sought outside help.
Okay.
They actually requested assistance from the U.S. Institute for Environmental Conflict Resolution.
Bringing in mediators, essentially.
Kind of, yeah.
Yeah.
The U.S. Institute looked at everything, made recommendations, and based on that, the agencies agreed to try something different, a collaborative process.
And this wasn't just, agency folks talking.
No, that was the key. It brought together a really wide range of stakeholders, private groups, public agencies, the whole mix.
And this collaborative group, it started meeting in 2002. It was a pretty big deal. 27 different agency and non-agency stakeholders involved.
27 voices.
Mm-hmm.
That sounds complicated in itself.
It was definitely a major undertaking, and this was all part of the bigger picture, the project development and the environmental review process you have to do under NEPA, the National Environmental Policy Act.
So how did they even start to unravel something that had been stuck for, over 50 years by then?
Yeah.
With all those different interests, were there, special tools they used?
Actually, yes. There was this innovative tool that turned out to be pretty instrumental in bridging those gaps. Sorry, couldn't resist the pun.
Yeah.
It was a computer design tool. It let all the stakeholders propose changes to potential bridge designs
Okay.
and then immediately see what those different ideas would actually look like,
So-
overlaid right onto photos and graphics of the area.
Oh, wow. So you could visualize the impact straight away.
Exactly. Being able to see the potential effects in real time must have made a huge difference in communication and, negotiation.
I bet. That kind of visual feedback must make those really complex trade-offs much easier to grasp. So what happened after this, 3-year process?
Well, it worked, mostly. They successfully navigated through all the intense negotiations. What's kind of remarkable is that 3 years of really focused effort, using this structured process, managed to resolve conflicts that had been simmering for over 50 years.
That's incredible.
Yeah, and they got through the NEPA process, which, as you know, is a major hurdle for any big project like this.
So a huge breakthrough then. Did everyone involved actually sign off on the final agreement? Was it unanimous?
Almost. Not quite everyone. While, the vast majority of stakeholders did endorse the agreement they reached, one key group, the Sierra Club, they didn't.
Ah, what did they do?
They filed a lawsuit to challenge the project.
Okay, so more legal challenges, and I think I read some of those went back to the river's special status, the wild and scenic thing.
That's exactly right. Specifically, the National Park Service, which is the agency that oversees the wild and scenic river system,
Hmm.
they were ordered by the court to provide more detail about the project's potential impact, specifically under the Wild and Scenic Rivers Act.
So more analysis needed.
Right. But instead of just supplementing their original finding, which had actually approved the project initially, the Park Service did something unexpected. They reversed their prior approval entirely.
They completely reversed it after all that.
Yes. They determined that the project, as it was proposed then, couldn't go forward without a specific exemption directly from Congress.
Wow. So it needed an act of Congress.
Pretty much.
Yeah.
So to move forward, legislation had to be introduced. And at the time one of these sources was written, that legislation was still pending.
What a complex journey. You really see how infrastructure needs bump up against environmental law, history, community feelings. Speaking of the history part, where does a structure like this bridge actually fit into the bigger picture of historic preservation, say, in Minnesota?
Well, historic preservation in Minnesota, guided by things like the statewide historic preservation plan, it's all about protecting different kinds of historic and cultural resources. That can be archaeological sites, landscapes, buildings, and structures.
And the National Register, they make a distinction, don't they, between, like, buildings for people and structures for other things.
Exactly. They classify different types of historic properties. So buildings are things mainly meant to shelter people in what they do. Think houses, offices, churches.
Got it.
But structures are properties built for other purposes, things like tunnels, dams, grain elevators, and bridges. That's the category the Stillwater Lift Bridge falls into.
And these preservation efforts, they happen locally too, not just at the state or federal level.
Oh, absolutely. The city of Stillwater itself has shown a real commitment here. In fact, the city got a Commission Excellence Award back in 2014, specifically for their education efforts and website projects tied to historic preservation. Shows a real local dedication.
Okay, so we have this bridge. It's recognized as historic. It's been caught up in decades of debate, legal fights. That structural side is really interesting. But what about keeping an eye on the bridge today? How do they monitor a structure like this, make sure it's, safe and holding up?
Right. Well, bridge conditions are constantly monitored. States have pretty robust inspection programs. Minnesota, for example, has MNDOT's Bridge and Structure Inspection Program Manual. These programs basically set the standards to make sure inspections are done consistently, thoroughly documented properly across the whole state.
And what about the parts you can't easily see, like under the water?
Exactly. That's where specialized techniques come in. MNDOT has actually been quite innovative here, using advanced stuff like underwater sonar.
Sonar, like on a submarine.
Sort of, yeah. They use it specifically to investigate the bridge substructures, the foundations underwater, which is crucial in places like rivers where the visibility can be, zero.
Makes sense.
And this approach, using sonar like this, it's actually noted as being pretty progressive among state transportation departments.
Did they actually use this sonar tech on the Stillwater Lift Bridge itself?
Yes, they did. There's a specific example from October 2015. MNDOT's team used sonar to inspect the Stillwater Lift Bridge right there over the St. Croix.
And what did that underwater scan show? What are engineers looking for with that kind of technology?
Well, the sonar was able to map out really clearly the extent of scour. That's the erosion that can happen around the foundations.
Right, the water washing away the riverbed?
Exactly. And it showed how much of the footing, the base, was exposed. The acoustic imaging was also precise enough to locate underwater debris and even model this known cavity, basically a hole, that was undermining some of the concrete around the foundation.
Finding undermined concrete. That sounds pretty serious. Does that mean the bridge was immediately unsafe?
Well, what it means is engineers get crucial data to make informed decisions. The findings back then indicated that this specific scour, the undermining, it might require some kind of intervention in the future.
Okay.
Getting this much better data through sonar compared to trying to, send divers down into murky water. It lets engineers make much better calls about where and how to prioritize maintenance and repairs. It's really about proactively managing the bridge's health based on good information.
So after all those decades of conflict, the collaborative attempts, the lawsuits, the ongoing high-tech monitoring of the old bridge, what was the final outcome for the transportation needs there, that busy river crossing?
Well, given that long-standing need for more capacity and all the challenges around the historic bridge's status and its limitations, eventually a new solution did move forward. According to information from around March 2016, a brand new St. Croix River crossing was actually under construction then.
A whole new bridge.
A whole new bridge, yeah, designed to handle modern traffic volumes and needs.
And how did the design of that new bridge maybe reflect some of the arguments that had gone on for so long? About the environment, the view.
That's a good question. The design of the new bridge did try to incorporate elements to minimize its visual impact. The piers, for instance, the supports in the river, they were designed to create a less obstructive view from the river itself, and they also had to deal with the huge temperature swings you get in this region.
Right. Minnesota winters and summers are no joke.
Exactly. So the piers have this sort of blade shape that allows them to flex and move. They actually expand and contract about 7 inches east or west between the peak of summer and the dead of winter.
7 inches of movement just from temperature. That's incredible engineering right there.
It really is. And just thinking about the scale of building that new bridge, it's massive.
I can only imagine.
Take the cross beams, for example, the big horizontal pieces. They were built in 3 stages, huge amounts of material. Just one of those cross beams, over 116 feet long, maybe 15 feet wide on average. It needed 478,000 pounds of rebar, steel reinforcing bars.
Wow. Nearly 500,000 pounds of steel for one piece.
Gives you a sense of the scale, yeah.
So looking back at the original Stillwater Lift Bridge, its whole story is just anything but simple, isn't it?
Not at all.
It starts as this vital connection, then it becomes the absolute center of this major, decades-long fight over environment versus history versus progress. It's a structure that needs advanced tech, like underwater sonar, just to check its health beneath the surface.
And ultimately, its complex story leads to this brand new crossing being built right alongside it, designed for today's world.
It really makes you stop and think, doesn't it? About the structures all around us. How do these kinds of tangled histories embedded right in our infrastructure, like this bridge, how do they shape the way we understand the places we live or visit?
Yeah.
And maybe, what's our collective responsibility in trying to balance all these needs? The lessons from the past, the demands of right now, and the future we're trying to build, especially in the things we construct